in iPad land. Sorry. I apologize. We haven't done much. Okay, but we do have guys. You help them. What's due on Monday? What's due on Monday? WebAssign. Where are we at on Friday altogether? Verse 31. Okay. We had a point not on a plane, and we're trying to find the perpendicular distance, and this is kind of where we're at. Okay, I put up notes for you guys, my notes from another book, and they're on Canvas in files. So they're there. So look at me, everybody look at me, and you guys in the grade, look at me. Okay, guys, you're getting way too much information. You're getting too many videos. You're getting so much crap sent to you. You can't process it all. You gotta treat it like a smorgasbord. Take what you want to eat out of it, just like when you go to D-Hall. Take what feeds you the best. What's your name back here? Raylan, what's your name?
Sean.
What feeds Raylan and what feeds Sean may be two completely different things. I'm putting up more than you guys can digest, but it's all there for you to help you. Does this make sense? Also, guys, the Zoom stuff, the Zoom office hours, and the Science and Math Learning Center, they're there for you. They have Zoom sessions just waiting for you. So if you're struggling on a homework, it's free. Just use them. What did I just say, Robert?
You said use the Science and Math Learning
Center. Use the Science and Math Learning Center. They're just sitting there waiting for you. Literally sitting there waiting for you. Staring at their screen, hoping somebody will zoom in. Except Zach, I don't know if they want you then. I want you. Okay, back to where we were. I want this distance right here. This right here forms a right triangle. Do you see the right triangle? We had a visual just a moment ago. It was a little easier to see in Nick's, Rhett's, and my right triangle. What's the distance of this vector b minus a? What's the distance of that vector b minus a? What expression represents the distance of that vector?
The norm of b minus a?
The norm of b minus a. I hate this thing. Okay. I never had one until a year ago. I refused to get a cell phone because I had 5 daughters. I never got a cell phone until a year ago when my mother-in-law moved in with advanced Alzheimer's. And then I suddenly needed a cell phone. I still don't know how to use it. Okay, so this is the norm of, what's the hypotenuse? The norm of
B minus A.
So mark it as that in your diagram. Now, my diagram's kind of a mess, but between your normal vector n and your vector b minus a, put the angle theta. Between your normal vector n and your vector b minus a, put the angle theta. And I'm going to do the same thing. Now, in terms of theta and the hypotenuse norm of b minus a, give me something in terms of trigonometry that would represent this distance, and which would also represent the distance from the point to the plane. In terms of trigonometry, using the hypotenuse and the angle theta, write down something that would represent that distance. Emily, you got anything for me there? What do you got for me?
The norm of b minus a cosine theta.
Perfect, Emily. The norm of b minus a times the cosine of theta. The norm of b minus. Anybody else get that? Okay, now of my vector products, guys, which one is attached to cosine? The cross or the dot? Of my vector products, which one's attached to cosine? The dot product. In fact, if we remember, A dot B, here's a flashcard. A dot B was equal to the,
Norm of A times the norm of B times cosine of A.
norm of A times the norm of B times the cosine of theta. Now let's look over here. We want the norm of B minus A times the, cosine of theta. Theta is the angle between B minus A and my normal vector. So if I did n dot B minus A, using that flashcard, this would be equal to the
Norm of the n
norm of n
times the norm of b minus a
times the norm of B minus A
times the cosine of theta.
times the cosine of theta. Does this make sense? Is this making sense, guys? Is this making sense? Okay, now look here, and look there. Look here, and look there. Are they pretty close? If you look here, and you look there, are they pretty close? What do I have too much of here? What do I have too much of there? What, I want this, but I got that. What do I have too much of over here? The norm of n. Could I get rid of the norm of n by dividing by the norm of n? Could I get rid of the norm of n by dividing by the norm of n? And so I could also, that would mean I would also have to do that to this side. And that's your flashcard. That flashcard represents the distance from the point to the plane. That flashcard represents your distance from your point to your plane. And I don't know which flashcard that is. Did we talk about parallel planes last time? Did we talk about parallel planes? Think about your notes. Did we talk about when two planes were parallel?
Yes.
Two planes are parallel when they're
Normal vector.
when their normal vectors are parallel, which I think makes sense. If two planes aren't parallel, then they think about it. If two planes aren't parallel, then visually what must happen with these two planes? They intersect. And I've got kind of an example of that right here. Here's maybe a plane, now it's not the same plane. And they're definitely, this is one plane where my hand is over here, and this is my other plane. What do we notice about these two planes? They intersect in the form of a line. Imagine you're building, and I've got one plane and I've got another plane. Might it be important to know that line of intersection? Might it be, if you got these two roofs, and they're coming together in three-dimensional space, might it be good to know the equation of that line? You're like, Dr. Warren, I don't care. You will care. Stand up again. I know you need this. I can tell already you guys need this. Don't breathe. Okay, what we're gonna do is we're gonna lightly hop up and down. Hop, like a little tiny bunny. Hop, like a little tiny bunny. Emily, hop, like a little tiny bunny. Okay, sit back down. See, now we're waiting. That was the most exercise I got all year, right there, that was it. Okay, when I say line, you say A plus TD. So imagine I've got two planes. So maybe there's one, n1 dot x minus a1 equals 0. And I've got another one like that, n2 dot x minus a2 equals 0. And they're not parallel, n1, that normal vector is not parallel to n2. n1 is not parallel to n2. So maybe I've got something like this. I've got one plane here with my head, and I've got my other plane down here that says Elmer's heavy duty trifold. Haley, I love just looking back right now because you're always smiling. Everybody else in the grid kind of looks drugged up, but Haley, you're smiling. Okay, so you. And in here, I can't tell if you're smiling or drugged. I can't tell. I can believe you're all smiling, but I don't know. No, I don't believe you're smiling. Now, what are we trying to do again? Oh, Dr. One, I forgot already. What are we trying to do again? We got these planes that are not parallel. What are we trying to do? Find the line of intersection. Now, when I say line, you write down what? When I say line, you write down what? When I say line, write it down. When I say line, you write down what? Okay, I just gave us two planes. They're not parallel. In fact, what is the normal vector to the first plane? Sorry, I'll read it all. 3x plus 5y plus 7z equals 8. And the next plane is 2x plus 4y plus z equals 3. David, what's the normal vector to the first plane? 3, 5, 7. Robert, what's the normal vector to the second plane?
2, 4, 1.
2, 4, 1. And you can see if you take the cross product of this, you're not going to get 0, 0, 0. You take the cross product of these two, you're not going to get 0, 0, 0. Also, there's no scalar you're going to multiply times 1 to reach the other. Either way you look at it. Okay, now, what's D? What's D in this game? What's D in this game, guys? What is D? When you said A plus TD, what's D in that? A direction vector. It would be a direction vector that would sit on the line of intersection. So now I'm going to try to put one there. My phone. Sorry, guys. Nick, can you grab that corner? Sorry, you sat in the front row, buddy. So I've got this. Do you guys see my direction vector? Do you see D there? That's what I'm trying to find. I want to find that first. Could you come up here? What's your name? Alex. Alex, just hold that corner. Just this corner right over here. Oh yeah, Alex, if you want to grab the other corner. So Alex is here helping me. Now imagine, Nick, let this be the normal vector to this plane. Nick, make that the normal vector to this plane. And I'm going to make it this blue vector the normal vector to this plane. Now, Nick, what I want you to do is I want you to come and put the green butt down here at this vector. Hold it normal, hold it perpendicular. And I'm going to do the same thing here. What do you notice the direction vector is? You guys look at the video up there. What do you guys notice the direction vector is in comparison to these two normal vectors? It's perpendicular to both. Okay, now, how do you think we can find a vector that's perpendicular to both the green vector and the tall blue vector? A cross product, You guys are so awesome. Thank you so much. I've got to ask, guys, I mean, like, do the 3D stuff help? I haven't used it that, I mean, does this help that much? I mean, is it better to see that, or should I just draw the crap on the board all the time? Seeing it's better, that's what I thought. I thought it's better to actually see it in three-dimensional space. So let me try to draw it. So I've got a plane coming like this. Then I've got some other plane coming like that. I've got this, I got a normal vector that's sitting like this. And I got some other normal vector that's sitting like that. We've got some other normal vector that's sitting like that. The planes aren't parallel, so they're going to intersect. They're going to intersect in a line. Okay, guys, you guys look at a wall in your room. Look at a wall. You guys in the grid. You guys in here, look at a wall. This is a plane, right? This is a plane, guys. This is a plane. Look at the floor. Look at the floor. The floor is another plane. Please say they don't intersect. Please say they're not parallel. How many of you recognize this wall is not parallel to the floor? They're perpendicular. Do they intersect? Do they intersect? And do they intersect in a line? Do they intersect in a line? Now, guys, look at the ceiling. Look at the ceiling. Look at the ceiling in your room. Are there a bunch of planes in that room? Are there a bunch of planes in that room? And not many of them are parallel. Not many of them are parallel. But what are two planes that are parallel in your room? Look around the room. What are two planes that are parallel? You're like, well, that wall and that wall. And the floor and the ceiling. Okay. Unless you live in the middle. Unless you live in the middle. There's nothing parallel in the middle. There's nothing parallel in the middle. In fact, in most student housing, nothing is parallel. Do not put 20 people on a deck. Do not put 20 people on a deck in student housing. Do not bring 20 people into your apartment in student housing. They will go through the floor. They will go through the floor. I've seen the aftermath. They had a dance party with 20 people, and all of them went through the floor. And the people that held the party got sued. Not the builders. I'm like, 20 people, come on. Okay, dance party. No, we're not dance party. Okay, I say line, you say A plus TV, and so this is going to be my direction vector. This is going to be my direction vector right here. Call that D. And what I'm doing is I'm taking this vector down to here. This is still N1. And I'm taking this vector here. And this is still N2. And I guess maybe I should draw it this way. Make that my D. And so D is, oh no, I want this my D. I'll make this my D. Then D is N1, D is N1 cross N2. So if you're looking for the line of intersection, your direction vector is the cross product of those two normal vectors. Now let's say you made a mistake. Let's say you made a mistake and you didn't recognize. Let's say you made a mistake and you didn't recognize that the planes were parallel. You have the floor and the ceiling, but you couldn't know that they were the floor and the ceiling. You're just looking at the equation. What would this cross product be to tell you that you got a mistake? What would that cross product be telling you, warning you that you made a mistake?
Yeah.
0, 0, 0. And so at that point, you're like, holy hell, they're parallel. Holy hell, they're parallel. They're not going to intersect. Okay. Nick.
Do all three of them have to be 0?
Yeah, Nick, all three of them have to be 0. All three of them have to be 0. Good question, great question. Okay, what else do I need? Sure, guys, I'm not used to teaching you in a mask anymore. I've kind of like gotten used to just having this room and talking to you guys. But I love having you guys in this room. It's so nice. What's your name over here? Lizzie, it's so nice to have you here. And then Bridget, it's so nice to have you here. Brandon, so nice to have you here. Cosmo, man, it's good to have you there. Roberto, I love seeing you in the grid. I love seeing you in the grid. Ava, I can't see you. Cameron, I can't see you, but you're there. You're there. Okay. Line. ADD, Dr.
A plus TD.
A plus TD. Do we have a D? Do we have a D? Do we have a D? Now we need a what? A. And you're like, ooh. You're like, Dr. Warren, how do I find a point that's on that line? It sounds impossible. It sounds impossible. How do I find a point that's on that line? Well, it has to satisfy, it would be a point that would have to satisfy this equation. It would be on that plane. But it would also have to be a point that would satisfy this equation because it would also be on that plane. Do you guys see? Do you guys see here? Do you guys see here? Do you guys see right here that the point on the line satisfies both plane equations? Can you visualize that? Can you see that there? How many unknowns do I have? How many unknowns do I have in these equations? How many unknowns are there? 3. How many equations do you have? 2. You're in awesome shape. You're in awesome shape. In fact, you can kind of see it here. How many points are on that line? How many points are on that line? How many points are on that line? Infinitely many, right? Aren't there infinitely many points on that line? So there's infinitely many possibilities for A. There's infinitely many possibilities for A. You're like, well, Dr. Warren, what's maybe the simplest way to try to figure this out? Go back to high school. Go back to high school. How many people in the grid and how many people in this room solved a system of 2 equations, 2 unknowns? How many people in here solved a system of 2 equations, 2 unknowns? How many people were used to working with X's and Y's? How many people are used to working with X's and Y's and doing that? So typically what I do is I just say, okay, just set Z equals 0. We'll just be looking for the point of intersection on the plane, on the floor, where the line hits the floor, where the line hits the floor. And this makes life easier for me, because if I'm looking at that point of intersection, Z is 0, so I end up with 3x plus 5y equals 8. And then the other equation would be 2x plus 4y equals 3. Now, do you guys think you could solve that? I mean, if I gave you time, do you think you could find the x's and the y's that would satisfy both of those? Do you think you could find that? And then once you're done solving the system of 2 equations, 2 unknowns, your A would be whatever that x was, I'll call it x star, because we're not doing that. Whatever your y was, call that y star, and then what did we force Z to be? What did we force Z to be in this game? 0. So that would be your A. And there's your A and your D for your A plus TD. There's your A and your D. Your A plus TD. Oh, chapter 12 is dead. Chapter 12 is dead. Put a dagger in it, like Johnny Mayfield did to the Buckeye O and almost killed me. Put a dagger in it. So everybody put a dagger in it. Right, come on, everybody pick up your dagger. Put a dagger in chapter 12. Now we're going to chapter 13. Calculus. Stand up. Stand up. You're going to need this. What time does class end? Okay. Stretch. Gently say, who's your mama? Look at the grid. Look at the grid. Say, who's your mama? Grid, look at these guys you can't see. Say, who's your mama?
Who's your mom?
Okay, sit back down. Sit back down. I'm going to quietly erase the board so you don't have to hear me. Robert, don't let me break my vectors. Are you guys feeling pretty safe as far as the distance in here? Are you feeling reasonably safe in here? Bridget, are you feeling okay back there in the corner? I'm just wondering. Raylan, is that right? Raylan, are you feeling okay there? Except when I walk back there, you're like Dr. Warren, you're like, David, are you feeling good? Guys, the most important thing is I want you guys feeling safe. Nick, are you pretty good, even though you're in the front row? At least I'm not spitting on you because of this. One time I was teaching, and I was like really excited, and spit came out all over like the first row. I felt so bad for them. I'm like, you should get extra credit for that. Another time I was teaching, and there's usually a table up here, and I noticed one of the legs was almost broken off, so then of course I had to break it off. And then I was using it a baseball bat, trying to say, this is the fundamental theorem of calculus. I swung, and I like really threw my hips into it like I'd be going into a ball. And I didn't realize there was a rubber plug in the thing, and it went flying across the room, right at Emily over here, hit her in the face. And I was just like, holy crap. And tears started coming down out of her eyes. It was my worst moment ever teaching. I'm like, I'm so sorry. I'm so sorry. She's like, I'm okay. I'm like, I'm not sure you're okay. I'm like, what if it would have been just an inch higher and hit her eye? That's where I was just like, okay, you gotta stop. You gotta stop. See guys, I love this stuff. I love this stuff. I can't help but think it's cool, and I want you guys to think it's cool too. I really want you to come. It's hard, but it's really cool what we can do with it once you own it. Calculus is about
limits and
derivatives and integrals. Oh my. We take limits, derivatives, and integrals of. Functions. Oh crap. Seriously, Dr. Warren? Yes. We're going to have vector valued functions. Say what I just said. Say what I just said in all the horror.
We're gonna have vector valued functions.
Vector valued functions. Say it again.
Vector valued functions.
Now, with your hand in the air, say vector valued functions.
Vector valued functions.
2 vector valued functions.
Vector valued functions.
Vector valued functions are cool.
Vector valued functions are cool.
Okay, good. So now say, Dr. Warren, give me a vector value function. Give me a vector value function. Say that. Okay. To do that, first of all, I'm going to go back to high school. Remember when we had alpha of x? Remember that? Remember when you first saw that? You didn't understand that either. Now you're like, oh, f(x). When we talk about a function, and those who've had me as a teacher better answer this correctly. What's the definition of a function?
take something in, give something out.
Something in, something out. Okay, Michael, I like that. You're picking something in from what set? There we go, Nick. Nick, say it again.
Domain and range.
Nick, get up to that mic and say it there. Get up to that mic and say it there.
Domain and range.
Okay, good. So there's a nice thing, another face, domain and range. Okay, so say this. A function
Function.
is a relation
Is a relation.
Relation.
that assigns to each element
Each element.
in one set called the domain, a unique element, say that,
Each element.
in a second set called the range. Okay, now repeat it. I'll start us. A function is a relation that assigns, good.
To each element in the domain,
Good, to each element in one set called the domain. We're close, guys. Can we land this plane like Con Air? Can we land this plane like
And a
Nicolas
unique
Cage did?
element? And a unique element in the range?
A unique element in a second set called the range. A unique element in the second set called the range. Okay, now let's try it again, choir. Let's try it again. A function is that assigns to each element in one set called the domain, a unique element in a second set called the range. That's a function. That's a function. So x here is coming from the real numbers. It's a domain. It's a domain value back in high school. What's coming out of the function, your f of x, is the range. Your f of x is the range value. Your f of x is the range value. So when you say f of x, let's pick our favorite function, f of x equals x squared. If you pick x equals 2 in the domain, if you pick x equals 2 in the domain, f of 2 is what value in the range? F of 2 is what value in the range? 4. Then you can plot that point. You can plot that point on your function. X, y over 2 up 4, over 2 up 4, there's a point on your function. Are you guys comfortable with this? I mean, we're starting here kind of back where we were. What's the graph? What's the graph of all those points? What's the graph of all those points make? What's the graph of all those points make? A parabola. Now, is a parabola a function?
Yes.
Does it satisfy the definition?
Yeah.
Now, what is the definition again? Other than I hate you, Dr. Warren. What is the definition again? A function
Is a relation.
in that to each element in the domain. So let's pick any real number here, maybe like -2. -2. It assigns to each element like -2 a what's the other part of the definition? A unique element in the second set called the range. So it's also f of -2 is 4, f of 2 is 4. So I've got to ask again, is it a function? Is it a function? Is f of x equals x squared a function?
Yes.
And the answer is yes. -2 is only assigned the value, -2 is only assigned the value 4. 2 is only assigned the value 4. But the moment you do something like this, where the parabola maybe gets drunk and falls over, like that, then I'm here at 2. How many values are being assigned now? How many values are being assigned now? 2. Then we're violating the what in the definition? Then we're violating the what in the definition?
Unique
The
element.
uniqueness. And that's why the vertical line test, that's why the vertical line test is what it is. You're like, okay, Dr. Warren, this is Calc 3. I know. So hold on. Here we go. I'm worried. You guys aren't aware enough to be worried. Write that down. R of T. What do you notice about R? What do you notice about R? What do you notice about R? What do you notice about R?
Not F.
It's not F, okay? What else do you notice? What else do you notice?
Is that fair?
It's a vector. Okay. T is still a real number. The domain is just like what we're used to, except we're not going to call it X. You'll understand in a moment. T is still a real number. What's coming out of the function, though, is not a real number. What's coming out of the function is a vector. So the domain is the real numbers, but the range is the set of vectors. Our range is a set of real value vectors. Now, how do you get to be a vector? How do you get to be a vector again? What's a vector? What the hell's a vector? What's a vector? What's a vector? What's a vector? What's a vector?
Order triple, 3 real numbers.
An ordered triple of 3 real numbers. An ordered triple of 3 real numbers. Okay, so this is going to be our definition. This is gonna be our working definition of a vector value function. For each element t in the domain, I'm gonna get different vectors in the range. And the way this is gonna happen isn't as scary as you might think. We're gonna have like an f of x here, a different f of x there, and a different f of x there. Instead of having one function, we're gonna have three functions. Now, how many people recognize we can't call this one f of t? F of t, f of t. How many people get that? How many people like, we can't call that f of t, f of t, f of t? Now, which location is this in that vector? Which location is that in that vector? And which location is this? And which location is this? So we're gonna call this x of t. Y of t. And then can you guess what the last one's gonna be? Can you guess what the last one's going to be? Z of t. Okay, so here we go. We're gonna pick t in the domain. Let's just say, okay, I've got t, and maybe I'll say, let's let it go from 0. Let it start from 0, and maybe have it go up to like 9. Let's pick t between 0 and 9. And my first component function is going to be t cosine of t. Like, oh crap, trig. T cosine of t. My next component function is going to be t sine of t. And my last component function is going to be t. Here's our very first vector value function. So let's see how you can do. Let's see if you can evaluate the function. So at your seats, you try to find r of 0. At your seats, you guys try to find r of 0. At your seats, you try to find r of 0. Sorry, what's your name again behind Robert? Lizzie. Do you have anything for me r of 0? Zero, because we're gonna have 0 times cosine of 0, 0 times sine of 0, and 0. Did anybody else get that? Okay, now let's try another point. And don't yell at me, please, don't yell at me. Let's try r of pi over 2. Try to find r of pi over 2. How many people are pretty good with that? Wherever you see a t, you're putting the pi over 2. How many people are like, okay, Doctor, when I get that? So we'd have pi over 2, cosine of pi over 2, pi over 2, sine of pi over 2, and pi over 2. Now you guys help me out. What is cosine of pi over 2? Think about the unit circle. Think about that unit circle. What's cosine of pi over 2? 0. You're at the
Yeah.
top. You're at the top. So this would be a 0. What's sine of pi over 2 up there at the top of the unit circle? 1. So this would be pi over 2. And this would be pi over 2. That would be pi over 2. Now let's plot. Let's plot like what we were doing back in high school. And the first thing that we notice is just how screwed we are. That's the first thing that we notice when we're thinking about it. Because let's see, this is the which axis? This is the which axis? This is the which axis? X. This is the which axis?
Y.
And this is the which axis?
Z.
What don't we have any room for? What don't we have any room for?
T.
T. There's no domain axis. Oh crap. Because I mean, like, remember if we have y equals f of x, you're used to graphing range, domain, domain, range, domain, range. But we got 3 functions. We got an x of t, a y of t, a z of t. There's no t-axis. We're only plotting range values. We're only plotting range values. So let's plot our first value. We had, when it was 0, we had 0. So that's just a vector pointing to the origin. Now let's say we're at pi over 2. Let's say we're at pi over 2. Then we got the vector 0, pi over 2, pi over 2. So you guys help me out. I would come out, some of you guys are just zoning. I can tell, look around the room. Do these people look in academic shape to you? Do they look like they're ready to be lectured to? Look at them, look at the beating that you're going under right now. It's like you're going back to basketball. Like, I mean, I don't know if you ever tried out for basketball. You ever played basketball? It's like the first day of conditioning. You guys in the grid look great. You're used to this. These guys look beat to hell. They look like they're about ready to vomit. They have no focus left. How many people came to class hoping to focus better? I mean, how many people like are showing up here today saying, you know, the grid didn't really work for me so well. I really like being in class. And now you're in class and you're like, oh yeah, I forgot all what this was like. I forgot how horrible this was. The nice thing is on Friday, we're all together. I'm whooping you guys into shape. I'm whooping you guys back into academic shape. I got you twice a week. I'm saving you. Okay, so we're here. Let's go back to here. 0, 0, 0. So I'm coming out the x-axis, 0. I'm going over the y-axis, and I'm going up the z-axis. So this would be like the next, that way. Now just like a line, when I say line, I hate you, Dr. Warren. When I say line, you say a plus TD. I know you won't listen to me. So, boys and girls, if I say line, you say a plus TD. But you recognize that it's not the set of vectors. The set of the damn vectors don't make the line. It's the set of the points the vectors point to. In the same way, when you think of R of t, I don't want you thinking of it. I don't want you thinking of it so much as the vector, but the point that the vector is pointing to. I don't want you to think of it as the position vector, but the point that the position vector is pointing to. Now, how many people realize this is kind of a difficult function to evaluate? How many people realize? How many people like Dr. Warren, this would be kind of a pain to actually evaluate. I mean, certainly, is pi over 2, is 0 in the domain? Is 0 in my domain? Is 0 in my domain? Is pi over 2 in my domain? Is pi over 2 in my domain? Okay, but if I'm going to plot all the values between 0 and 9, are you guys going to say I quit? Are you guys going to say I quit? Or are you going to say I quit? If I say plot that, so guys, open up your graphing routine. Open up your plotting. Open up that easy plotter. Go to Canvas. You guys just stay here. I'm going to do it for you. I'm going to be your workhorse. you guys will be able to turn and see this. I'm gonna do the same thing. Bridget, can you see from all the way over there?
Yeah.
Okay, so let me get rid of this. The first thing, guys, is just click on this thing here. Once you're there, oh shoot, I'm not sharing anymore. Can you guys see? Can you guys see this? Can you see it? Is it sharing to you? Cosmo, are you seeing, man? Okay, so the first thing I want you to do is just click on this box right here. Just click on that box. And I want you to change your X min to -10, your X max to 10. Same thing with your Y min, and so on. And then over here, oh, I've got scale factor set. I'm a moron. Let me put these back to 1. I want check marks at 2. Change these to 2. Grab. Okay, that's a lot better. Okay, the next thing I want you to do is go to select, and you guys, I know you guys won't focus in this room at all. What did I just do? I hit graph, now I'm going to, and then I want you to go to R of T, which is your space curve. So we'll do that. Let me get rid of this one. Okay. Where you see the X of T, help me out, Nick. What's our X of T function? It's not T squared, but it's,
Talk about the T cosine.
it is the T cosine T. And you guys enter the same thing at home. And then I've got my Y, which is T,
Sine.
and I got my Z, which is
T.
T. In my domain, what's the domain? I'm not going between 0 and 30, I'm going between 0 and 9. And so let's just see what this looks like by making it visible. So this is my space curve. This is my space curve right here. What does it look like it's doing?
Spiral.
This looks like it's spiraling up, doesn't it? I mean, in fact, if I look at it like this, you can kind of see that spiral. You can kind of see the spiral there. Let's make it go a little bit further in the domain. Maybe we'll have it go to 18. And so now you can begin to see that spiral there in 3-dimensional space. Now let me trace the point. Okay. So now what I'm going to do is I'm going to animate, and what's going to happen is, guys, it's going to show you the position vector. I know you guys can't see. It's going to show you the position vector that's going to point to this as we go along. Do you want to see that? You guys want to see that? So let me do that for you. So let's draw those position vectors. That's so fun. And we can make it go a little slower. It might not like this. Let's do 400 points. And so there you can see how that's doing that. So stop sharing. So when I say line, you say A plus D. When I say plane, you say A. When I say R of T, you say space curve. Say that. Space curve. It is so much cooler than the Space Force. It's so much cooler than the Space Force. When I say R of T, you say space curve. When I say R of T, you say space curve. Okay, now I want you guys to write down your own space curve. Come up with your own unique space curve. Come on, write down your own unique space curve. And you guys at your seats over there in the grid, you do the same thing. Come up with your own unique space curve.
I'm just drawing it.
Just give me the functions. Yeah, just draw. Give me your functions. Give me an R of t. Okay, once you're done, hold it up. Once you're done, once you have your space curve, hold it up. Let me see what other people's space curves are. Hold up to the screen. Let me see your space curves. What's your space curve? So Emily, what's your space curve for me? What's your space curve?
T plus 3,
T plus 3,
2t,
2t,
and hopefully t plus 5.
3t plus 5. Okay, so this is Emily's. Emily had t plus 3, 2t, 3t plus 5. Can anybody guess what space curve? Can anybody guess what space curve Emily's is? What's the shape of Emily's space curve? What's the shape of Emily's space curve? And let me help you. I've got to ask, if you guys did your scalar multiplication, if you did a scalar multiplication and a vector addition, would you get that back? If you did a scalar multiplication and you did a vector addition, would you get that back? What is this? A plus T D. The shape is a line. Okay, guys, I want you to go plot your space curve. Give yourself a domain, maybe between 0 and 9. Go plot. You guys in the grid, go plot your space curve. Go plot yourself your space curve. Go ahead, plot your own space curve. Now, Nick. I'm trying to think. Whose name don't I know well enough yet? Emily?
Lizzie.
There's one right here. Okay, right here.
Hunter?
Man. Hunter, what was your space curve? Let's plot Hunter's space curve. I'm gonna plot Hunter's.
It was another line.
There's another line. Okay, guys. Nick, I think you're gonna be creative for me. You didn't have a line. What was your space curve?
I had sine of t, tan of t, and cos of t.
So I'm gonna plot his. Tan of t?
Yeah.
Sweet! Sine of t. What was the second one?
Tangent of t.
Tangent of t. That's got a vertical asymptote. This is gonna be sick. And what's the last one?
Cosine of t.
Cosine of t. Now, Nick, I'm not gonna go between 0 and 18, because we would make the whole world end. Okay, I'm gonna go between like 0 and pi over 4. Get rid of this puppy. And let's just plot this thing. Ooh. Okay, so you can see, Nick, I'm not getting too much there as I look at that. So I'm let's go a little bit closer. Let's go to pi over 2. Let's see how angry it gets with us. So there, Nick, that's kind of what you're looking at. There you can see it's going off and then it's just flying up just like that. It's flying up just like that. There's your space curve. Okay, Hunter, what was yours?
Mine was t minus 4,
T minus 4,
4t,
4t,
and t plus 4.
and t plus 4. Now, what do you guys anticipate this is going to look like? What do you guys anticipate this is going to look like?
A line.
So let's do that.
Line.
And there you can see his line, and it's a line segment. It's a line segment because we're only going between 0 and pi over 2. Let's take it to 20. And now suddenly we can see we got a line going like that. Okay, one more. Lizzie, man, what's yours? Lizzie, what's yours?
2t, 2 plus t, and 2 minus t.
2t, 2 plus t, and 2 minus. What was it, 2 minus t?
Yeah.
Okay, let's plot Lizzie's now. So there's Lizzie. You can see your line's a little bit different. Your line's a little bit different than what Hunter had. Okay, okay. There's not much you guys can plot in your head. How many guys are realizing this? When I say space curve, you say, I'm going backwards. When I say space curve, you say R of t, okay? Now I know, when I say R of t, you say, there's not many shapes that I'm gonna be able to write an equation down that you guys are gonna be able to immediately tell me what it looks like. If I say a plus td, you know that is. If I say a plus td, you know that is a line. But I'm going to show you guys at least a couple that we can identify. I'm going to show you guys at least a couple that we can identify. And we're going to end class with this. This is a reasonably simple one. So what's my space curve? What's my space curve? What's my space curve?
A spiral.
It does end up being a spiral. It does end up being a spiral, but could you read off for the people in the grid? What's my space curve? It's cosine of t, sine of t, and t. Okay. This is my which axis? This is my which axis, guys? This is my which axis? This is my which axis? This is my which axis?
Z.
And this is my which axis?
Y.
I don't have an axis for who? I don't have an axis for two. I don't have an axis for who here, guys? I don't have an axis for who? T. There's no t axis. Now if I look at x, my x coordinate is really cosine of t. I'm not even writing it x of t. I'm not even writing. My y is sine of t. And my z is t. Now this is the trick that works a lot. When you've got sine and cosines, what is the fundamental identity from trigonometry? If you think about all the identities that they had, what was the one that was the most useful?
Sine squared plus cosine squared equals 1.
Perfect, Gordon. Sine squared plus cosine squared equals 1. So if I look at here, cosine squared plus sine squared is equal to 1. But that would be like saying x squared plus y squared is 1. Now make your Algebra 2 teachers so proud of you. Make your Algebra 2 teachers so proud of you. What shape is that?
Circle.
A circle. Where's the center of the circle? Where's the center of the circle?
0.
0, 0. What's the radius of the circle?
1.
So down here in the xy plane, let's draw a circle of radius 1. Okay, now let's just imagine z. Let's imagine z is able to do whatever it wants. Let's imagine that z is allowed to do whatever it's want. Okay, so I know that x squared plus y squared's always got to be equal to 1. So I know I'm always going to have to be on this circle. Now z can do whatever it wants. If I let z go up and down, what shape am I going to create? Imagine that I've got this ring in bubbles, and I'm gonna pull it up, or pull it down. What shape are you gonna create when you go up or down? What shape are you gonna create, Robert? A cylinder. If I go up and down, I'm gonna create a cylinder. You're like, that's one, damn it. You said RFT was a, I say RFT, you say space curve. This is not the space curve. This just gives you a place where the space curve is gonna live. The space curve is going to live on this cylinder. The space curve is gonna live on this cylinder. As t starts at 0, let's put 0 in. I would have put 0 in. I would have at 1, 0, 0, 1, 0, 0. So it's going to start here. Then as t goes through its domain, notice the z coordinate grows. The c coordinate grows. And so what's going to happen is, maybe that's the position vector. It's just going to start sweeping around that cylinder. It's just going to start sweeping around that cylinder. I know. It's been an hour and 15 minutes. I know. But Lizzie, this is so cool. Lizzie, I know you don't think it's cool. Lizzie, this is so cool. David, freaking cool, right? I mean that we can do this, that we can build spirals, that we can build all kinds of curves in three-dimensional space, and then determine supports, columns to support these curves. Go work for Disney, man. Build these incredible structures that will just blow people's minds when they come to your theme park. I mean, just think about some of the stuff that we can do that you could no longer do before this class. I'm giving you the world. I know you don't want it. Like, it scares you. But I'm giving you a brand new set of tools to work in three-dimensional space. But calculus is about limits, derivatives, and integrals of functions. All we've talked about is a function. We haven't talked about limits or derivatives or integrals. Oh my, yeah, you know. Now you guys are really, Bridget's like, I get the oh my now, Dr. Wayne. I really get the oh my. What's your name again? Brandon, thanks for coming today. Guys, thanks for being here. Hopefully it wasn't so horrible. I know it was horrible, but hopefully it wasn't so horrible. Thanks, guys. Thank you, guys. I will see you on Friday. All together one. That's the JMU motto. Except when it's in state, out of state. See how clear that looks? That's Zoom. It doesn't look like that for you guys. It just doesn't.
No,
It's just
really,
horrible.
depressing,
I mean, look at that. I mean, that would be okay to learn from. See you, Robert.
Thank you.
It's like you guys are like, oh, I got to take off cataracts. I came to class and removed my cataracts so I could actually see.
Thank you.
Thanks, Fred. Lizzie, nice to meet you.
Nice meeting you too.
David, and Raylan, right?
I will be here on Friday.
Okay.
Anyway, you could set up the iPad.
I'll set up the iPad in the room.
Perfect.
There's not a camera for me to do that, but yeah, I'll set up the iPad.
Perfect.
And I'll try to remember to start it.
Okay,
That's not the bigger issue.
There you go, everyone.
Thank you.